Welcome friends. In this particular video, basically I will be talking about multiple regression using two independent variables. So in the previous video, I have talked about what is multiple regression and I talked about simple linear regression using one independent variable. I hope you have watched the previous video. I will request you all that you should watch the first video thoroughly before watching this video so that you can understand multiple regression in better way. So first you watch that particular video, then you can proceed and watch this particular video which is on multiple regression. The previous video was on simple linear regression using one independent variable. So in this particular video, I will be talking about multiple regression, what actually it is. I will also take few examples and demonstrate to you how to solve multiple regression. Particularly, I will be taking example using two independent variable. So it will be easier for you to understand. Basically, for more than two variable, that is three variable, four independent variable, it becomes quite difficult to get the coefficients terms like beta 0, beta 1, beta 3 like this. The calculations becomes very complicated. So we perform those calculation using some statistical software like SPSS or R. But in this particular video, we will be discussing on multiple regression using two independent variable. So after watching this video, and if you have watched the first video also, I think you will be very much clear about what is the main principle working behind performing multiple regression. So I welcome you, all of you, in this particular video. Just try to watch the full video so that you can understand multiple regression in better way. So let us first try to understand what is multiple regression. We have understood what is simple linear regression. Simple linear regression using one independent variable, that is only one independent variable is there. And from that you are trying to predict the dependent variable. So we are constructing in that simple linear regression using one independent variable. We are trying to get a model of it. We are trying to get a regression equation. But here we have to understand that multiple regression is an extension of simple linear regression. It is used when we try to predict the value of a dependent variable, target or criterion variable. It is also called dependent variable, is also called target variable or criterion variable, based on two or more independent variables. So if two or more independent variable will be there, then it will be called as multiple regression. So using two or more independent variable, predicted variable, predictor variable, explanatory variables, when we predict a dependent variable, then it is the case of performing multiple regression. Let us take one example. If we want to predict the scores of students based upon number of study hours and number of classes attended, then it is the case of multiple regression, because we have got two independent variable, two predictor variable like in that hours of study and the number of classes attended. So based on these two independent variable, we are trying to predict the scores obtained by the student, or we are trying to construct a regression equation using these two independent variable so that we can estimate these test scores. So this is an example of multiple regression. So let us now see the equation of multiple regression. The multiple regression equation is given by y equal to beta 0 plus minus beta 1 x1 plus minus beta 2 x2 plus minus, it will go like that, and the last term will be beta and xn. So because multiple independent variables are involved, so multiple beta coefficients are there. So for x1 beta 1 is there, for x2 beta 2. So if n number of independent variables are there, so n number of beta coefficients will be there, including beta 0, which is the intercept point of the regression line on the y axis, and epsilon is the error term. So you can see here y is the dependent variable, or the for which we are obtaining a multiple regression equation. So it is the dependent variable beta 1, beta 2, beta, and all are the regression coefficients. Beta 1 is the regression coefficient of x1, beta 2 the regression coefficient of x2, beta and the regression coefficient of xn. Beta 0 is the intercept point of the regression line on the y-axis, and epsilon is the residual or error terms. So this is the simple understanding of multiple regression equation. Now, as I told you that I will be discussing in this particular video on multiple regression using two independent variables. So by using two independent variables, you can see the simple regression model can be given by beta 0 plus minus beta 1 x1 plus minus beta 2 x2 plus epsilon. So x1 and x2 are two independent variable. Beta 1 and beta 2 are the regression coefficient respective to x1 and x2. And beta 0 is the intercept point of the regression line and the y-axis. And epsilon is the residual or error terms. So as I have explained in the earlier video also, y is our data, and this is the multiple regression equation. So this is the line of fit, means this particular beta 0 plus minus beta 1 x1 plus minus beta 2 x2 will give you the multiple regression. That means by using this particular beta 0 plus minus beta 1 x1 plus minus beta 2 x2, you will predict the value of y. It will give you y cap. So it is the line of it, and then there will be some certain residual terms or certain error term. That means you will not be able to exactly predict the value of as observed y data. You will not able to predict that one. So there will be certain residual term for that, plus the predicted value will, when we will combine that predicted value with the residual term, it can be added, it can be subtracted. That's why plus minus both signs are there for epsilon or residual term. So it can be little bit more than the exact value, or it can be little less than the exact value. So the combination of the predicted value and the residual will give you the exact data. So I think from this particular representation you have understood what is the meaning of regression. So we have to reduce the term epsilon so that our model is the best model or is efficient model. That is, you are able to predict y in much closer terms. That means our residual term is very insignificant. It is very less. So we have to try to get a line of fit which is the best fit line, and from which we can very closely predict the value of y. So this is the objective of performing multiple regression, so that so that there is less regression between the predicted value and the exact value. So that is the main objective when you are going for performing multiple regression, or our we will tell our regression model is best fitted if we are able to reduce the epsilon or residual term. So in this particular video, as I told you that I will be demonstrating to you a problem based on two independent variable. By using two independent variable, we have to predict the value of y, or the dependent variable. So you have already understood how to get the multiple regression equation solved, or how to get the multiple regression equation when one independent variable is there. That problem I have already solved in the previous video. But in this particular video, because the number of independent variable has increased, and in the next stage, if you are going when you are going to take three independent variable, four independent variable, then it may become more complex. So basically I will be going for using the deviation method. And you know, we have used deviation method whenever we are going to solve standard deviations, whenever you are going to get the value of standard deviation, whenever you are going to get the value of mean, whenever you are going to get the solution of correlation of coefficient. Basically deviation methods are used to simplify the steps so that you can easily calculate the things. So you can also do with this exact scores also of x and y. You can always do that one, and that also I have done when I did that particular, when I solved the questions in the previous video. Here we will be going to use the deviation form of the different scores. Deviation from the mean, I will be taking that one, and that one I will be using to solve this regression. If you will use the exact score also, you will get the same result, but it will be little complex when number of observation will be quite more, and when number of independent variable will be also very large. So just try to understand what is our deviations. I have tried to explain it here. So y bar is the mean of dependent variable. Dependent variable, that means our observed variable, and y mean is the mean of that dependent variable. And then x1 and x2 are our independent variable, observed independent variables. So x1 bar is the mean of independent variable x1, and the x2 is the mean of variable x2 bar is the mean of independent variable x2. Then I have taken small y. You just see summation of small y equal to summation of y minus y bar. And similarly, you can follow it summation of x1. So you can just see summation of y equal to summation of y minus y bar. And similarly, summation of x1 is equal to summation of x1 minus x1 bar. Basically, we'll perform y minus y bar. We will also perform x1 minus x1 bar. I will explain it using one example. You can always understand that one. So you just try to see the symbols, the notations which I am going to use. So you be very much specific that small y is summation of y minus y bar, and similarly sigma of x1 equal to sigma of x1 minus x1 bar, sigma of x1 minus x1 bar. And you can always know that sigma of x2 is sigma of x2 minus x2 bar. So you just try to understand these are the raw scores, the exact score. From there we have converted it into deviation form. That means we have get the x1, small x1, and then small y and small x2. So you'll just try to understand when we'll solve the problem, we will get it how actually it is being working. So let us see the next step so that you can understand it. So proceeding further, you just try to see now the terms are in the form of uh, deviations form. That means you have got the forms in deviation form. Now we have got all the notations in the form of deviation form, that is x1 y, and you already know what is x1, what is y. So x1 will be multiplication of x1, small x1 into y. Similarly, x2 y is summation of x2 into y. So this is the next notation. And similarly, summation of x2 small x1 x2 is equal to multiplication of product of x1 into x2 and their summation. So what is summation of x1 square? Sum of square of x1, and you know already what is x1, small x1. And similarly, x2 square is equal to sum of squares of x2, and you will know what is x1 and what is x2. x1 is capital X1 minus x1 bar, and x2 is equal to small x2 equal to capital X2 minus capital X2 bar. And what is y? Y is small y is capital Y minus y bar. So this is the meaning of small y, small x1 and small x2, and these different symbols, different terms which we will be using. We will be using x1y, sigma of x1y. We will be using sigma of x2y. We will be using product of x1, x2 sigma. And we will be using some sigma of x1 square and sigma of x2 square. And from where you are getting this x1, small x2 and small y, that is, let me again explain. small y is equal to capital Y minus y bar. Similarly, small x1 equal to capital X1 minus x1 capital X1 bar, and small x2 equal to capital X2 minus capital X2 bar. So once we will solve one problem, then we will get it, how actually it is working. Now, as I told you that in the previous video also, we have to get the coefficients, regression coefficient and the intercept. So in the previous video, we have got the beta 0 and beta 1. Now we just try to see here the formula of beta 1 and the formula of beta 2. So this is the formula of beta 1. You can see the formula for beta 1 is sigma of x1y multiplied by sigma of x2 square minus sigma of x2y multiplied by sigma of x1 x2 divided by sigma x1 square multiplied by sigma x2 square minus sigma x1 x2 whole square. Similarly, beta 2, just you use in place of 1, you put the term or index as 2 and you will get beta 2. So here x1y was there, now it has become x2y. So you will get the beta 2 term just by replacing the denominator is same. You can see this denominator and this term denominator is same, just in the numerator term x1 is replaced by x2 and vice versa. So you have got the coefficient beta 1 and beta 2, and the intercept of on y-axis is given by this equation. You can see it is y bar minus beta 1 x1 bar minus beta 2 x2 bar. So here you are using the mean score. This is from the exact score, beta 1 x1 and beta 2 x2, and once you will get beta 1 and beta 2 using the deviation forms, you will be able to calculate what is beta 0. So let us see one example first. So let us see one example. Let us see, this is one example. Suppose we have the following data set with dependent variable y and two independent variable x1 and x2. So these two are independent variable x1 and this is the other x2 variable, and this is the dependent variable. So we have got x1 x2, so it is, we have to perform regression and just try to see what is the result. These are two independent variables, so you have to perform the regression here and we will see the results, what is happening. Okay, so first we have to calculate the coefficients of regression. That is, we have to get the values of beta 0, beta 1 and beta 2. So for doing that one, let us see how we can do that one. So this is our values. This is the values from the question, that y, x1 and x2. It is from the question, it is already given here. We have got 8 observations. 8 observations are there, and we have obtained the values, mean values of y 181.5, mean value of x1 that is 69.375, and mean value of x2 is 18.125. Now, as I told that what is the meaning of small y? Small y is y minus y bar. So we have to calculate for each y, we subtract from its mean and we will get y minus y bar. So suppose for the second value it is 215 minus 181.5 and you will get the value as 33.5. So similarly all the values are obtained, and if you will add that this one, you will get a 0 here. Similarly for x1, small x1, it is summation of it is for small x1, it is x1 minus x1 bar. So these are the values from each x1, subtract its mean value and you will get 62 minus 69.375 is minus 7.375. Similarly 78 minus 69.375, that is 8.625. So we have got x1. Similarly x2, from each x2 you subtract this mean. X2 mean is 18.125 and we'll get x2. So next thing that we have to use, because if you remember the coefficient, regression coefficient, we need x1y, we need x2y, we need x1, x2, we need x1 square and x2 square. All this is small x1, x2, y, this all we require. So we will get x1 into y. So for this small x1 into y we will obtain, that is first one is minus 26.5 into minus 7.375. So we have got this one. So we will first get x small x1 into y. So for each x1 and y, small x1 and y, we'll do the multiplication and we'll get all the terms in this particular column. Similarly, in the second column, this column, this column, this column, this particular column, if you will multiply each x2 into respective y, we'll get x2 into y. And then we have to multiply x1 into x2. So this x1, each x1 will be multiplied by x2 and we'll get these terms in this particular column, this particular column. And then we have to get x1 square. So simply you square these terms, and you will get these values, this x1 squares, and then similarly we'll get x2 square. So we have got this sum value also. We have got sum of x1 y is equal to 1162.5. Sum of x2 into y is minus 953.5, and the product of x1 into x2 summation is minus 200.375. Similarly, x1 square is 263.875, and similarly x2 square summation is 194.875. So these all values we have calculated, and these all values are required whenever we will calculate beta 0, beta 1, beta 2, and most specifically when you have to first calculate beta 0, first calculate beta 1 and beta 2. From that you will calculate beta 0. So after obtaining those values, this is summation of x1 y that we have seen in the earlier slide. And similarly, summation of x2 y is minus 953.5. x1 x2 summation is minus 200.375. Summation of x1 square is 263.875, and summation of x2 square is 194.875. And this is the equation of beta 1. X summation of x1 y into x2 square, summation of x2 square, minus summation of x2 y multiplied by summation of x1 x2, divided by summation of x1 square multiplied by summation of x2 square minus summation of x1 x2 square. So once you substitute these values from here, whatever values we have obtained, if you substitute here, then you will get beta 1 as 3.147893. So this formula we have used, and we have calculated beta 1 as 3.147893, and these all values x1 y, x2 y, summation of x1 x2, summation of x1 square, summation of x2 square, that we have already seen how it has been obtained. So again we have got the same values, and we of x1, summation of x1 y, summation of x2 y, summation of x1 x2, summation of x1 square, sigma of x2 square, and similarly by substituting in the values of equation of beta 2, we will get beta 2 as minus 1.65614. So you can see the formula of beta 2. The denominator is same as what is there in beta 1. You can see this factor 11 to 72.5. It is same in the previous coefficient also. When we were calculating that one, the denominator was same, only the numerator is different, and there is just we have to replace, or we have to just make some interchange between x2 and x1, then you will get the beta 2 equation, and the after substituting the values we have got beta 2 as minus 1.65614. Now last is to calculate beta 0. We know the formula for beta 0 is beta 0 equal to y bar minus beta 1 x1 bar and beta 2 x2 bar. And here x1 and x2 are the from the exact score, the real score, not the deviation value are not there. It is capital X1, capital X2. So as we have obtained beta 1 and beta 2, we will just substitute these values here, and we will get, we have also obtained the value of x1 and x2 bar. It is this one 69.375, and then x2 bar is 18.125. We have already seen this one. So once you substitute these values, you will get beta 0 as minus 6.7425. So we have obtained the value of beta 0, beta 1 and beta 2. So now we are in the position to get the regression equation, and most specifically it is multiple regression equation. Now we can write it down. So substituting the values of beta 0, beta 1 and beta 2 into the regression model, which I have already told you for the regression model or regression equation for two independent variable is given by y equal to beta 0 plus minus beta 1 uh, x1 plus minus beta 2 x2 plus minus epsilon. So we have got the equation of line of best fit, and then this is the equation of best fit. You have got the equation of best fit, that is, and I hope you can recall our equation is the data is equal to line of fit plus residual. So this is the equation of line of fit from which we can estimate dependent variable y cap, which is equal to minus 6.7425 plus 3.147893 minus 1.65614 x2. So what is the interpretation of all this term? So beta 0 is the constant or intercept, and it is equal to minus 6.7425, and it indicates when both the predictor variable are 0, then the value of y is minus 6.7425, or we can say when the coefficient of x1 and x2 is 0, or when the values of x1 and x2 are 0, then we can say that the value of y, or the dependent estimate of y, will be equal to minus 6.7425. Now what is the meaning of regression coefficient beta 1? It is equal to 3.147893, and it indicates that as x1 increases by 1 unit, so if this x1 will be increasing by 1 unit, there is an increase of 3.147893 in y. So y value will increase by 3.147893, assuming that x2 is held constant. So you have to assume that x2, when x2 is constant, and if x1 is changing by 1 unit, then there is increase of 3.147893 unit in y. Similarly, what is the meaning of regression coefficient beta 2, which is equal to minus 1.65614? So it indicates that as x2 increases by 1 unit, there is a decrease of 1.65614 in y, assuming x1 as constant. So there is decrease in y by 1.65614, because we know that the coefficient beta 2 is having minus sign. It is minus 1.65614. So if x2 will increase by 1, there will be decrease by 1.65614 in y when x1 is kept constant. So in the next step, we have to calculate the coefficient of determination, and for that we have to first get the ANOVA table, and we will do the ANOVA analysis first. So just try to see, this is our case. In our case we have got 8 observation. Our y value is given in this particular column. You can see these y values are here, and x1 x2 is also written here. And so y cap we have got, y cap is obtained by using that multiple regression equation of line of fit that we have obtained. By using that line of fit, we have to get the value of y cap. So we'll get the value of y cap here. So we will get the regression in the value of y, in the estimated value of y, by using the formula y cap minus y mean, mean of y. This value, mean of y, that is 1452 divided by 8, whatever value comes. So that mean value we have to subtract from each y cap. So we will get these values here, and we will square it. So we will get the regression sum of squares. So this particular column gives you the regression sum of squares. So this particular column has been squared, each term has been squared, and if you sum it, then it is the sum of regression. Similarly, to get the residual values is obtained by the exact value of y for each observation minus the predicted value of y for each observation. So here, suppose for the first value 155 minus 147.0235, whatever value we have got, that one we have kept here. So whatever, after subtracting each value of y with its y cap value, we have got this value. So these are the residual values for each observation. So, and then this particular column gives you the residual sum of square. So the value in this particular column, if you will add this value 203.5667, this is the residual value, residual sum of square value. This is the regression sum of square value. Now to get the total sum of square, first we have to subtract each y from its each observed value of y with its mean. So each value of y is subtracted with its mean. So we have got for first minus 26.5, then 33.5, and once you square it, you will get the total sum of square, and when we'll add this, you will get total sum of square. So this is the total values, sum of square values. You will get this one. If you will add these two values also, if you add these two values also, you will obtain this particular value. So we have got summation, regression sum of square, we have got residual sum of square, and we have got total sum of square. So now we are in the position to construct the ANOVA table to perform the F test. Okay, so after obtaining the value of sum of squares of regression, sum of square of residual, and sum of square of total, we can construct the ANOVA equation table so as to perform the F test. So here the F test is conducted with the null hypothesis in background that there is no relationship between the independent variable and the dependent variable, or we can say that regression coefficient of the independent variables are 0. So there is no relationship existing between the dependent variable and the independent variable. So if this F value becomes insignificant, then our regression equation fails to predict y on the basis of using x. Or we can say in other way, the f should be significant, the f value should be significant, and so that we can say that our x or our independent variables are somehow able to predict the value of, or somehow we are able to predict the value of y using x. So we have to test this condition, we have to test that hypothesis, that if we are getting the null hypothesis rejected, or if the null hypothesis can be converted into alternative hypothesis, and our regression model or the line of fit is actually working or not. So the sum of squares I have already discussed. The degrees of freedom also I have discussed in the earlier video also, but let me again make you understand here also. So degrees of freedom for regression is given by k, number of variables being estimated. So we know that the number of variables being estimated here is the formula is, so degrees of freedom of regression is k minus 1, where k is number of variables being estimated. So how many variables we are estimating, or how many things we are estimating? First, whenever we are solving multiple regression situation, we are in our example we have estimated three values, that is beta 0 value, the coefficient or the constant term, or the intercept term, the beta 1, the regression coefficient of variable x1, and beta 2, the regression coefficient of variable x2. So 3 is the value of k, minus 1, that is 3 minus 1, 2. Sometimes we can also say that the degrees of freedom for regression is the number of independent variables involved. So in this case, we have got two independent variables, so degrees of freedom is 2. Now, what is the residual value? So residual value is n minus k. N is the number of observation or number of rows in the study. So we have got 8 observation. So the n value is 8, and k, as I already told, it is 3. So the value of residual degree of freedom will be 8 minus 3, that is 5. And total is addition of degrees of freedom of regression and degrees of freedom of residual. So we have got degrees of freedom of regression as 2, and we have got degrees of residual value of degrees of freedom, residual degree of freedom as 5. So it is 5 plus 2, that is 7. And in other way we can also get, it is total is equal to n minus 1. So we have got 8 minus 1, that is 7. So this is the degrees of freedom of respective regression sum of square, residual sum of square, and the total sum of square. Now what is mean square? So to get the mean square, we have to divide the respective sum of square by its degrees of freedom. So we have got regression sum of square divided by 2, because degrees of freedom here is 2, and the residual sum of square is residual sum square divided by n minus 3. So here we will divide by 5, because we have got n as 8, 8 minus 3 is 5. And then to get the value of f, we have to divide mean sum of square regression by mean sum of square residual. So let us substitute these values. So substituting these values, we have obtained the regression sum of square as 5238.677. Residual sum of square is 203.5667. Degrees of freedoms are 2 and 5 respectively. So mean square is the sum of square divided by degrees of freedom. So we have got these two mean square, and once we divide this mean sum of square of regression by divided by mean of sum square of residual, we get the f value as 64.30. So while comparing with the ANOVA table, the standard ANOVA table for 2,5 degrees of freedom, we will get that this value is quite high. That's why we can say that. So that's why we can say that our uh, null hypothesis is rejected, and we can say there is significant relationship between the independent variable and the dependent variable. That is, our model is capable of predicting y using the x values. Now we have to get the coefficient of determination. So what is coefficient of determination? Coefficient of determination, or it is denoted by r square, it explains the power of our regression equation or multiple regression equation. That means how much our multiple regression equation is efficient to predict or estimate the value of y. So the value of coefficient of determination varies from 0 to 1. So if the value is very close to 1, that is our uh, multiple regression is quite strong, and it is quite we are able to get the best line of it. We are able to reduce the residual value, and our multiple regression is quite powerful in estimating the values of y or the dependent variable. So if you see the formula for r square, it is explained variance by total variation. So it is regression sum of square by total sum of square. So if you substitute this value, we'll get the value as 0.962638. So if you talk in percentage, it is 96.26% of the variation in the dependent variable y is explained by variable x1 and x2. So we are capable of explaining the variation, or we can say 96.26% of variation in the dependent variable can be explained using the independent variables x1 and x2. Now we will be calculating the adjusted r square value. So what is adjusted r square value? So whenever there are multiple independent variables involved in a multiple regression, then we have to go for calculating the adjusted r square value. Basically, it is done to see that whether our regression equation is overfitted. The obtained r square value is adjusted for the number of variables included in the regression equation. Basically, this is used to obtain whether there is a shrinkage. Basically, it is used to estimate the expected shrinkage in R square that would not generalize to the population because our solution is overfitted to the data set by including too many independent variables. Because we have, suppose we have got multiple number of independent variables, so by calculating the regression coefficient, we might be very particular to that particular sample data set, and it cannot be generalized to a population. So we have to get the adjusted r square value to see that to what extent, if our adjusted r square value is closer to the calculated r square value. If the adjusted r square value is very much lower than the calculated r square value, then we can say that our regression equation is overfitted, and actually it is not, and actually it cannot be generalized to the population. So we need to get the adjusted r square value, and to obtain the adjusted r square value, which is calculated very much on the basis of number of independent variables that we have estimated. In our case, we have estimated three regression coefficients: beta 0, beta 1, beta 2. So to calculate the value of adjusted r square, the formula is 1 minus n minus 1 divided by n minus k multiplied by 1 minus r square. That is the calculated r square. And we already know what is the number of observation. K is the number of variables or regression coefficient that we have estimated. In our case, it is 3 because we have estimated beta 0, beta 1, and we have calculated beta 0, beta 1, and beta 2. So from that, we can easily see it is 1 minus 8 minus 1, that is 7, and in the denominator 8 minus 3, that is 5, multiplied by 1 minus the obtained value of r is 0.962638. So once we substitute the value, we will get the adjusted r square value as 0.947693. So this value is also quite higher. It is not so much deviated from the calculated value of r square. So we can say that after adjustment also 94.77% of variation in the dependent variable y can be explained using x1 and x2. So after understanding the multiple regression equation through one example, we have seen how multiple regression equation or line of fit is obtained, how to perform ANOVA, and how to get the coefficient of determination and adjusted r square value. Now we will be doing now we will take one more example to understand it in better way. So here we have got one problem involving 10 students. So 10 students marks are here, exam scores are here, and in the as independent variable, revision time and lecture attendance is given. X1 and X2 are these two independent variable. So basically we are trying to investigate the relationship and effects of revision time and lecture attendance on exam performance. So we have to perform a regression analysis and interpret the findings, interpret the result. So here two independent variables are there, revision time and the lecture attendance, and based on that we have to estimate the exam score through a line of fit. So we have to see if this particular regression equation holds or not, and how we can do it. We have already done, but let us again revise it. So we have got the values of y, x1 and x2. You can see here x1 is, y is here, x1 is there, and x2 is there. Then we have to get the deviation form. We have to get small y, small x1, small x2. So already the formula is written there. Small y is capital Y minus y bar is 57 in our case. Similarly, x1 is a capital X1, each x1 subtracted by mean of x1, capital X1, here it is 18, and small x2 is x2 minus mean of x2 bar, it is 12 in our case. You can see here it is 12. Then we have to obtain x1 into y, small x1 into y, multiplication of this x into y, each value. We have got this, and then we have to also calculate x2y, small x2 into y, and we have to calculate x1 into x2, small x1 into x2, and then lastly we have to calculate x1 square and x2 square. We are getting all these all values, we are getting because we have to obtain the intercept beta 0 and this regression coefficient of x1 and x2, because these all values are required as per the formula of beta 0, beta 1, beta 2. These all values will be required. So we have obtained this one. We have to obtain the sigma or summation value of each column. So we have got this 956, this is 900, this is 524, then 576 and 504. These all values we have to use it to obtain the value of beta 0, beta 1 and beta 2. So after getting those values, sigma values, 956, this value 956, this 900, 524, 576, 504, these all values we have to substitute here according to this formula. We will substitute, and after substituting we have got beta 1 as 0.65. Similarly for beta 2, again we have to substitute the values, and we have got the beta 2 value as 1.11. And lastly, because we know what is the mean value of y, that is 57, and the mean value of x is 18, x1 is 18, and mean value of x2 is 12. So after getting the values of mean of y, mean of x1, mean of x2, and after obtaining the value of beta 1 and beta 2, we can always get the value of beta 0, and our beta 0 value is 31.98. So by using the value of beta 0, beta 1 and beta 2, we can get the line of fit, or we can estimate the value of y, because we have got the beta 0, beta 1 and beta 2, the regression coefficient and the intercept. So after getting the values of beta 0, beta 1 and beta 2, we can get the regression model, we can get the equation of line of best fit, and that the line of best fit is 31.98 plus 0.65 x1 plus 1.11 x2. So what is the interpretation of beta 0? So here also beta 0 means it is a 31.98. It means that when the predictor variables are 0 or the regression coefficient is 0, then the value of y is 31.98. Or we can say when your regression, when your study revision time is 0, or even attendance is class attendance is 0, then we have got the test score is as 31.98. Practically it is not possible that your revision time is not there, or but we have got a situation where we can say that beta 0 is 31.98, which indicates when both the predictor variables are 0, then the value of y, or estimated value of y, is 31.98. Now, what is beta 1? Beta 1 is regression coefficient for x1, the variable x1, that is revision time, which is 0.65. It indicates that as x1 increases by 1 unit, there is an increase of 0.65 in y, assuming x2 be held constant. So when x2 is constant, our number of classes is kept constant, then if there is an increase of revision time by 1 unit, there will be increase of 0.65 in your exam score. Similarly, beta 2, for beta 2, we can say that it is the value of beta 2 is 1.11, and it indicates that when x2 increases by 1 unit, there will be an increase of 1.11 in y, assuming x1 is held constant. So if number of classes increases by 1 unit, assuming x1 or revision time kept constant, there will be an increase in exam score by 1.11. So this is the explanation of line of best fit. We already know that this is the situation. We have got situation from the observed set of data. We have got a line of best fit, that is beta 0 plus beta 1 x1 plus beta 2 x2. There is always a residual value. Our focus is to minimize that residual value so that our line of best fit is very much close to the exact data. So now we have to perform the ANOVA, analysis of variance, to determine the coefficient of determination. So we have already seen that one. So this is our situation. We have got y, we have got y values, we have got x1, x2, and we can always estimate y cap using our line of best fit. We can estimate y for each value of x1 and x2 because we have got beta 0, beta 1 and beta 2. So we can estimate y, and then we can get the regression values for each y. We can get the regression value, that is y cap, that is estimated y value minus y mean. So here in our case y mean is 57. Y mean is 57 because 570 divided by 10 is 57. So if we get for each value of y, we will calculate the regression value. So it is y minus y bar, y minus y bar. And then if we will square this term, then we will get regression square. And this particular column will give you, when you will add this particular column, then you will get regression sum of square. In the next column, you have got the residual value, which is calculated by the observed value of y, this value of y, is value of y, to the predicted value of y, estimated value of y. So for each particular observation, we will get this one residual value, and in the next column we will square it so that we will get regression sum of square. So regression sum of square value is 13.670. Last one, we will get the to obtain the total sum of square, we have to do y minus y bar. For each observed value of y, we will subtract it from its mean, and then we will square it. Each term we will square it for each observation, so we will get uh, total sum of square, that is 160, that is 1634. So we have got regression sum of square as 1620.47. We have got residual sum of square as 13.670, and total sum of square is 1634. So after this, we can go for constructing the ANOVA table, and we can go for F test. So for going for F test, which start from the hypothesis, the null hypothesis, that there is no relationship between the independent and dependent variables. So for the success of the regression model, or for the success of deriving the best line of it, it should be significant, so that our null hypothesis is rejected, and we will obtain we will be in the position to say that there is a significant relationship between the independent variable and the dependent variable. So we have got the regression sum of square here. We have got residual sum of square. This is the ANOVA table requirement, and then we have got the total sum of square. And I already told you what is degrees of freedom for regression. It is number of independent variable, or we can say it is k minus 1, where the k is the number of variables being estimated. So in our case, we are estimating three things. We are estimating beta 0, the intercept value. We are estimating beta 1 and beta 2, so it will be 3. So here we can say that it is 3 minus 1, 2. And here in the second case, residual is n minus k, so n is 10 here, 10 minus 3, that is, it will be 7. And total sum of total degrees of freedom is given by regression degrees of freedom plus residual degrees of freedom. So here the value is 2, and here the value is 7. So our total degrees of freedom will be 9. And to get the mean squares, we have to divide the respective sum of respective regression sums with its degrees of freedom. And to get the F value, we have to take the ratio of mean sum of square of regression and mean sum of square of residual. So you can see when we substitute the values, we have taken the values from the previous calculation. We have got these degrees of freedom, which I already told you. So we have obtained mean square values, and from this mean of square values, we have obtained the F value, and we can see this F value is very high, and we can see this value is very quite significant. That is, our null hypothesis is rejected, and we can say that we are in a successful position to get the regression model or estimate the best line of it. There is a significant relationship between the independent variable and the dependent variable. Now, as I told you, that we have to calculate the coefficient of determination, which is given by explained variance by the total variance, or the regression sum of square by total sum of square. So if you substitute the values, we will get that this value is coming 0.99172. That is, we can say that 99.17% of the variance of the variation in the dependent variable marks is explained by variable x1 revision time and x2 lecture attendance. So we have got the value as 0.99172. So we can say that 99.17% of the variation in the dependent variable marks, exam marks, y, is explained by variable x1 revision time and lecture attendance, that is x2. By these two independent variables, we are able to explain 99.17% of the variation in the marks. But as I told you that because number of independent variables are involved here, we have to calculate the adjusted R square value. So to get the adjusted R square value so that we can check if our model is overfitted or not, or if our model can be generalized to the population or not, we will use this formula adjusted R square. Formula is here. So I have already explained this one. These all symbols or all this notation. What is the meaning of n? What is the meaning of k? So we have got the value as 0.989. So it is very close to our actual R square value. So we can say that our adjusted R square is, our regression model is quite effective. There is it can be generalized, and we can say that with adjustment 98.9% of the variation in the dependent variable y is explained by independent variables x1 and x2. So in the general term, in generalized condition for the population, after calculating adjusted R square value, we can say that previously it was more than 99%, but after doing the correction, we can say that 98.9% of the variation in the exam score can be explained by x1 and x2. So in this particular video, I have talked about multiple regression, and particularly I demonstrated using two independent variable how you can get the regression model, how you can get the best line of fit equation, and further how to perform f test to test the success of our regression model, and further how we have got the coefficient of determination R square values. So manually it is quite possible when one variable or two variable or two independent variables are involved. But when there is case of three variables or more than three variables, then, and if their observation is also quite large number of observations are there, we have taken examples of 10 observation, 10 cases maximum. But if there are 100 number of cases, then the calculation becomes little difficult. So we have to use some statistical packages like SPSS or R to perform this particular regression analysis, and it can be easily done using SPSS. So in the upcoming video, I will be doing this regression analysis. Particularly first I will start with doing regression using our examples only, the examples which I have taken in the first video, which I have done manually, first problem, or the problems which I have discussed there, and then the problems which I have discussed involving two independent variables. This all problems will be solved using SPSS package. Further I will also show some other problems so that you can understand how effectively, how easily we can do regression using a statistical package, and how the results obtained by those statistical analysis, how those results can be interpreted or can be understood. So keep watching. I hope you have liked this particular video. So subscribe to this channel. Thank you.